Okay, double angles, geometrically speaking. It says, for example 3 here, it says, given the triangle to the right, find each of the following. So we have sine of 2 theta for A. Well, we know the sine of 2 theta, given the identities above, is equal to 2 sine of theta cosine of theta. And so if we knew sine of theta and we know cosine of theta, we could just plug them in, couldn't we? So let's go find those. Well, when we're looking at a right triangle, we know sine of theta, remembers, our y over r, and cosine of theta is our x over r. So we just need to find what x, y, and r are going to be. Alright, so now our triangle's drawn a little weird, or we could say opposite, adjacent, hypotenuse, and that almost might be better on this one. So actually I'm going to switch that over to it. So this is 2 times, now remember when you're looking at sine, that's opposite over hypotenuse, and cosine was adjacent over hypotenuse. And I'll show you how to look at it from the other direction as well. Alright, so 2 times. Well, do I know the opposite? I do. Here's my angle theta. So this side is opposite. But also notice it goes up and down like the y-axis, okay? So that's why we could have said y over r. So we know our opposite is 1 over, do we know the hypotenuse? Well, we don't. So we've got to go find that hypotenuse, okay? So remember that x squared plus y squared equals r squared. Or you could say a squared plus b squared equals c squared. X is like my x-axis. It's going to go left and right. So notice it's a 4. The y-axis, the y is like the y-axis. It goes up and down, so it's a 1. And we're after that radius. We're after that r. We're after that hypotenuse. So work this out. Add them together. So we get r squared is 17. And so we know r is plus or minus the square root of 17. Remember, r is a radius. It's a distance. And distance is always positive. So we know it's going to be the positive square root of 17. Alright, so I'm going to plug that in here. Times adjacent. For my angle here, we can see that the 4 is adjacent over the hypotenuse, which we just said was square root of 17. And so now we're just going to multiply them. Well, remember with fractions, you multiply across the top and you multiply across the bottom. So I'm going to take this 2 and make it into a fraction. So I'm going to put it over 1. So when I multiply the top, 2 times 1 times 4, I get 8 over 1 times the square root of 17 times the square root of 17. Well, 1 times anything is anything, and square root of 17 times itself will just give us 17. So we get 8 over 17 as our answer for sine of 2 theta. Alright, so then we got cosine of 2 theta. Well, guys, we have an option. Which one do we want to use? I've already found what sine of theta was and already found what cosine of theta was, so it really doesn't matter which formula we use. And since my hypotenuse has a square root, I'm going to use something that's got a squared in it, which I think, yeah, when I glance back, they all have a squared in it, so it's not going to matter. So it's just a personal preference, okay? We're all going to get the same answer at the end. So I'm just going to go ahead and use that first one. So it says cosine squared of theta minus sine squared of theta. Well, if you recognize that you just found in the previous one, we had said that sine of theta was equal to, was it 1 over the square root of 17? And we said cosine of theta was equal to 4 over the square root of 17. I can just plug those in now. So I know cosine is going to be 4 over the square root of 17 squared minus sine, which is 1 over the square root of 17 squared. Now remember, when you square a fraction, you can look at it as it means to multiply it by itself, or the top and the bottom are both going to get the 2, or the square. Either way. So the first, I'm going to go ahead and just write it out twice though, because if all else fails, this is the best way to do it. So we get 16 over 17 minus 1 over 17, because you multiply fractions straight across, which gives us 15 over 17 for cosine of 2 theta. And then it asks for tangent of 2 theta. So we're going to go grab the formula for tangent of 2 theta, which it tells us is 2 tangent of theta over 1 minus tangent squared of theta. Well, I haven't found tangent of theta yet, so I'm actually going to come up here where I have sine of theta, cosine of theta written, and I'm going to go ahead and put tangent of theta. Remember, tangent is opposite over adjacent, so it's going to be the 1 over the 4. Alright, so now we're going to go plug this in our formula. So we get 2 times tangent of theta, which we said is 1/4, over 1 minus tangent squared, so the 1/4 squared. Remember, in that numerator, you're multiplying with fractions. So you get 2 over 1 times 1 over 4, which is going to give us 2/4, which reduces to 1/2. Over, in the denominator, we got 1 minus 1/4 squared is 1 over 16. Now, it's up to you how you do it here. I'm going to go ahead and get rid of my little fractions. So I know I need a 2. I also need a 16. 16's bigger, so I'm going to multiply everything by 16. Alright, so when I do that, in the numerator here, the 2 and the 16 reduce. The 16 becomes an 8. 1 times 8 is 8. Over 16 minus second fraction, those 16's cancel, so I got 1, which gives me 8 over 15. And so there is what tangent of 2 theta is equal to.